So we come to the final formal session today, and it is by no means the least, because at the end of the day, without ports, we will not be able to deliver anything. So we have to deliver a keynote speech is Rear Admiral Joe Servidio. He has over 4 decades of maritime safety, security, environmental protection and response, and operational experience in the public and the private sector. And of course, we're very pleased that he sits on our advisory board. And joining him on the panel, we have Myrto TRIPATHI, and she will be known to many of you as the president and founder of the Voices of Nuclear and is currently Director General of the TerraWater Institute. And we also have Vincent Zabielski, partner at Pillsbury, and Richard Vaughan, Senior Maritime Consultant at ABP Mer. So please give a warm welcome to our final set of speakers. Thank you.
Well, good afternoon, and thanks for your time and for being here at this last session before cocktails. I'm looking to kick off this session by providing some background information on where port electrification or onshore power systems for ships and waterfront facilities currently stands and where and how it's growing. Some opening caveats. Although I know that this is the European Summit, I am going to initially talk about activities at some of the U.S. ports who have had onshore power systems in place for decades. Right now, many of the California ports are seen as providing the most onshore plug-in opportunities, the broadest set of mandates to plug in, and the most onshore power lessons learned. All of my remarks are focused on high voltage onshore power systems, 6.6 thousand or 11,000 volt systems, and cruise ships are the largest segment of the maritime fleet that are currently plugging in globally. Many container ships in California are also plugging in due to emission reduction mandates, and both Fuel EU and decarbonization initiatives are increasing non-cruise ship plug-in opportunities. Bottom line up front, the number of installed and planned onshore power systems is growing most rapidly right now in Europe and in Asia. Most of the onshore power systems being used, like those in California, have mandated that vessels use them or plug in order to reduce ship-generated air emissions and to reduce port community public health risks, not necessarily for decarbonization purposes. And where provided, the cost-benefit calculations often are favorable only due to the public health and the carbon reduction aspects of the analysis. That said, there are some examples where ports and ship operators have identified win-win opportunities to install onshore power systems at costs that are comparable with burning fuel. The first onshore high-voltage power system installed for commercial vessels in the U.S. was actually installed about a quarter century ago in Juneau, Alaska. The Alaska Light and Power Company, which powers the city and the borough of Juneau, as well as cruise ship and other ships plug-ins, is still totally reliant on only hydroelectric power, which energizes the local and totally isolated grid. The Port of Los Angeles began offering alternate marine power systems, or onshore power, over 2 decades ago. These are not new systems. The U.S. Environmental Protection Agency conducted a shore power technology assessment in 2017 and updated that assessment in 2022. There's a lot of information in the assessment along with some cost-benefit analysis. In the 22 update, the report notes, relative to U.S. ports and terminals, quote, commercial shore power has grown significantly since the 2017 report. So how significant was this growth in the U.S.? The U.S. Maritime Administration says there's over 300 ports in the U.S. As you can see in this chart, which is lifted from the EPA's 22 assessment, there aren't as many ports currently providing shore power to commercial ships as many might think, with the majority of those ports, as I said before, in California. Most of the benefits highlighted in the EPA's assessment are emission reduction related and reflect community health benefits associated with reduced illnesses. And there is a local mandate for ships to use the onshore power systems wherever it's possible. Now, as I mentioned before, the majority of vessels consistently using shore power globally are cruise ships due to their large hotel loads and regularly called on terminals. This chart is taken from the Cruise Lines International Association's website. It shows where worldwide there are cruise ship berths with onshore high voltage systems. The information is current as of last month, and the number of ports in Europe with active, which are onshore power systems shown in green, as well as funded, which are shown in black, and planned that are shown in blue. Much of this growth is a result of initiatives like port decarbonization plans, national plans like China's current 5-year plan, which targets increasing shore power, and EU requirements like the Fuel EU maritime regs that in January 2025 impose life cycle greenhouse gas requirements for ships, and by 2030 requires passenger and container ships to connect to shore power if they have any stay longer than 2 hours. This slide is an excerpt from CLIA and more clearly identifies ports with funded and planned cruise ship onshore power systems. I don't have a graphic showing container or non-cruise terminals offering shore power. But in Europe right now, there are a lot of onshore power systems just coming online or being put out for bids, with actual installations more limited. Hamburg and Rotterdam have had container ship plugins for a little bit over a year. Richard will provide a little bit more information with regards to Southampton OPS or onshore power systems. And just since June, Toulon announced France's largest OPS was completed. A tender notice was issued for the design, supply, installation, commissioning, maintenance of shore power at London Gateway and DP World Southampton. Copenhagen inaugurated the largest OPS for cruise and ferry vessels, funded in part with 11 million euros from EU's Connecting Europe Facility Transportation Program. Naples announced an OPS project funded under Italy's National Recovery and Resiliency Plan. Algeciras announced a 800 megawatt, 500 million euro renewable and battery storage OPS investment to be made by 2030. And Gothenburg announced the completion of a 2-week pilot program supplying OPS using a hydrogen-powered generator. In addition to the Chinese and South Korean ports shown here in Asia, both Singapore, Japan, and other ports are looking at or planning to install shore power. And the growth of onshore power in Asia is almost rivaling that in Europe. From my experience working with cruise lines, however, not all onshore power systems in the U.S. are able to provide firm, which is power available at all times, or adequate levels of power. And not all were well planned with an eye towards future needs. For example, in Red Hook, Brooklyn, only half of the regular calling cruise ships can plug in due to tides, ship lengths, the fixed onshore plug locations, and most significantly, grid stability concerns. Onshore power at a new cruise ship terminal in New York that initially was looking to provide onshore power was abandoned due to the complexity of the New York City grid. In Juneau, which again relies totally on carbon zero hydroelectric power for all needs, only 2 berths are outfitted with shore power, with often 5 or more ships calling on Juneau during the season. Onshore power in Juneau has not been available in times of low water, usually towards the end of a cruise ship season, during dry years, as well as when maintenance is needed. That was 6 weeks or more last summer. When a cruise ship plugs in Juneau, it's equivalent to another city of Juneau going onto the grid. and the isolated grid is limited in the available power it can provide. Vessel power demands and average and peak loads can be significant. Both the US EPA and the European Maritime Safety Agency, or EMSA, have provided guidance to help developers of OPS, including load demands for various types of vessels. Cruise lines and container vessels have made substantial vessel infrastructure investments to enable their ships to plug in and meet, for example, the California Air Resource Board or CARB emission reduction requirements. More than 120 CLIA member cruise ships, about 46% of the fleet, installed systems for accepting shore power as of the end of 2024. Despite having these systems installed, commissioned, and available, cruise and other vessels in California are asked not to plug in to the grid due to heat emergencies and at other times when grid is in question. And this has happened almost every year. Last year was the first year it didn't happen. Additionally, in California, container vessels have also seen an inability to plug in despite having installed systems. The vaults, where ships plug into a substation, were not planned with the current length of container ships, and at times, the substations just don't have enough juice for multiple ships to plug in. This lack of adequate, reliable, and firm power has forced vessels that were counting on plugging in to instead burn MGO while in port, or for container ships and car carriers to use one of the limited number and somewhat to very expensive emission barges to suck up the ship's exhaust via a bonnet high in the air that fits over the vessel's stack. The photo in the upper left shows an emission capture barge in California, which not only adds waterways clutter and increases navigation challenges, but also it's added safety problems. That boom has hit vessel infrastructure, vessel stacks, terminals, cranes, and other types of things. For a ship capable of plugging in, and it's about $1 million or more CapEx investment to be able to put the equipment on board that can't plug in, it's a double whammy, as the unplanned vessel emissions requiring diesel generators on MGO negatively affects the vessel's carbon intensity scores, and capital outlays go unused. Some European ports have challenges with adequate levels of onshore power, grid stability issues, and significant plug-in costs. Operating companies, primarily cruise lines, who made substantial sustainability commitments to plug in wherever available, are navigating a tightrope due to the extraordinary costs of power in some places. They pay whatever fees, fines, or costs in lieu of using a port's onshore power system. I'm at the end of my allotted time, but in summary, the number of installed and planned onshore power systems are growing, most rapidly in Europe and then in Asia. Most of the onshore power systems previously installed have mandated that vessels plug in order to reduce generated air emissions and improve port community public health, and in some cases achieve decarbonization initiatives. Though in Europe, there are questions with regards to the decarbonization initiatives maybe driving more of that onshore power growth. And there's questions about how much the source of an onshore power is being looked at, and if true well-to-wake analysis is being used. Cost-benefit-wise, calculations are often favorable only due to the public health and air emission reduction aspects of the analysis. That said, there are win-win opportunities and examples. In Miami, a partnership between the port, 5 cruise lines, the Florida Power and Light Company, supportive politicians, 22 million in federal and state grants, enabled more than 21 cruise ships with 350 calls to plug in Miami in 2024. I think new nuclear, small modular reactors with greatly reduced EPZs will and must be part of the port and/or facility electrification and decarbonization future. And a number of places floating clean energy centers make sense for reliable, firm, adequate, decarbonized, known cost, resilient, and if needed, mobile port power. In addition, the thermal energy generated with floating nuclear could also help provide clean hydrogen, synthetic fuel production for port infrastructure, desalination, or other uses. So again, thanks to Core Power for putting on today's event, and thanks for your attention and time. I look forward to taking questions during the panel session or thereafter.
Thank you, Admiral Servidio. Good afternoon, everyone. My name is Thomas Davies, and I'm the Director of Analytics at Core Power. And I won't be letting Charlotte forget that she forgot to introduce me after this. I think, yeah, thank you. It's a really great overview, I think, of the current landscape that the port infrastructure and their electricity demand are looking at. And I think it makes two things very clear. The first is that we are looking at a rapid expansion of onshore power supply planning, and also sort of much broader electrification of these ports and surrounding infrastructures. And this is driven both by public health and clean air mandates, as well as these decarbonisation goals we're looking at. But it's becoming quite clear that the infrastructure we're looking to rely upon, particularly the grid, often isn't ready to deliver this firm, reliable energy at the scale that is required. Now, ports, once solely viewed as gateways to trade, are now starting to emerge as critical nodes in this energy transition. The UK port electricity consumption is expected to increase tenfold between 2016 and 2050. It seems then that the origin of this energy, though, itself is possibly overlooked. This is where FNPPs, we think, can provide a scalable, resilient, and reliable energy at the scale that is required. And with that, I'd like to start turning to our panellists. So if I could ask them each to give a brief introduction and their sort of initial thoughts on the topic. So Richard, please.
Yeah, hello. First of all, a quick thanks to Core Power, not just for the invitation today, but for saving the best topic till last. So yes, my name is Richard Vaughan. I work for ABP Myr. ABP Myr is essentially the consulting arm of Associated British Ports. Associated British Ports is the largest private port group in the UK. They own and operate 20 ports throughout the UK of various sizes, one of which is Southampton, which, as we know, is a key cruise port. So they have 5 dedicated cruise berths, I should say, sorry. 2 of which are electrified to provide power to the cruise ships. However, what sounds a little bit strange is that they can actually only provide the power to 1 berth at any one time, due to constraints in the grid. So it's a real problem for ABP. I think from what I gather, if they're going to upgrade the grid, you're looking at in excess of a decade to get the power to the port. The connection is 16 megawatts, which is enough for a single cruise ship. And in actual fact, that 16 megawatts is the same as the entire port estate. So you flip a cruise ship on, you're doubling the port's power demands.
Fantastic. Yeah. I mean, the scale of it is something that's sort of overlooked quite often.
Yeah.
Myrto, if I can turn to you next, I think someone that has worked in the terrestrial nuclear industry for a while. I guess from the nuclear industry perspective, floating, how has that to sort of change the deployment conversation? And I guess why would then it make a compelling use case in ports?
Thank you very much, all. Thank you for the invitation and also for all the work that is going on. I think it's very humbling, and I want to start with that, to see the stakes we have to address collectively but also the quality and the number of people that are actually ready to take on that challenge. And thanks to Co-Power for showing so much leadership in that. That being said, I'm very happy to represent the nuclear industry here. And from the nuclear industry's perspective, floating nuclear power plants, FNPPs, are a real change of paradigm. We are living through, the nuclear industry, many changes of paradigm lately. Not the least one of them is that nuclear is finally and fully recognized as a decarbonation tool for the European Union and the rest of the planet. But more than that, it's also being finally and fully recognized as a tool for competitiveness, which is very important, as you imagine, as a driver, as a fundamental driver for change. What FNPPs bring in a change of mindset is that it essentially sets nuclear free from multiple leeches that it has been historically bound to. And those leeches are what? Are connection to the grid, or having state-level counterparts, and being framed in a market perspective that essentially limits it to provide power and nothing else, and to be a competition to other power production technologies. So it's really no surprise that end users, industrial end users, know so little of nuclear industry ecosystem and functioning and mechanisms today. FNPPs allow all those three bonds to be broken, and the nuclear industry to be able to challenge the fossil industry eye to eye, finally. So it means lifting up grid constraints, mechanical, technical constraints. It may be frequency, it may be availability of power, continuity of availability. In case of peak demand, industries may be asked to load shed in some cases, and that can be a killer. Grid constraints are planning constraints as well. You may need the power somewhere at some point, and the grid operator may tell you to wait 5, 10, 20 years before it's your turn to be connected. What it opens up as well, it brings perspectives beyond the sole power. So power, you made a compelling argument for it, but nuclear can do so much more. It can evidently bring process heat, carbon capture, energy for carbon capture, for desalination, for hydrogen production that will lead to e-fuels production. It can also serve communities around with district heating and so on. It can serve additional businesses such as freight, which are so important in ports because you can become the energy hub that actually feeds rail, feeds road traffic, lorries, and so on. And finally, what ports and FNPP bring to the nuclear industry, it's an operational environment that is used to multi-energy systems, which is really not so often, is used to pile on top of each other different regulations, land and sea and everything in between, and also an environment and human resources that are used to challenging environments and that are used to handle risks and have a physical appreciation of what the risk is and not an imaginary one. Because when you're at sea, you know what you're facing and you don't need to fantasize the risk. I mean, it's there.
Brilliant, thank you. And then Vincent, I guess from a legal but also an engineering background as well, it tends to beg the question, I guess, of why it's not been done before. And I think in some of the other panels earlier, we've discussed about actually this is not the first time we've looked at this and there is a precedent. I wondered if you could talk a little bit about that from our conversations.
Certainly. My name's Vince Sabielski. I'm a nuclear energy lawyer at the same firm as Alina at Pillsbury. And we didn't compare notes ahead of time, but if we had, we would have seen that we both are approaching this from a historical perspective. I think the most inspiring speaker for me today, out of all these exceptional speakers, was Tim Stone's kind of call to arms. When Tim said earlier today that our parents and grandparents built the infrastructure of this country, and we've kind of run it into the ground over the past few decades. People tend to forget that the first nuclear power plant was built here in the UK in 1956. That was the first commercial nuclear power plant in the world at Calder Hall, and it ran reliably into the noughties. Our parents and grandparents also built the Savannah, which has come up a couple times today. It was the first commercial nuclear-powered ship. That was in 1959. It was commissioned, and that ran until 1972. Sturgis was another ship that was a barge-mounted nuclear power plant. It's about 10 megawatts. It was commissioned in 1967. In January 1967, it had its first criticality. And in July of the following year, 1968, it was towed down to the Panama Canal. The Panama Canal needs lots of water to operate. It also needs a lot of water to run the hydro plant. So when there's droughts, you don't have enough water to run the canal and run the power plant at the same time. So nuclear power to the rescue. The Sturgis was, with its reactor, was towed down there, and it ran for about 8 years until it was replaced by combustion turbines. So that's, I guess I'm reminded of, I think it was St. Paul in Corinthians said, there's nothing new under the sun, and indeed that's nowhere near more applicable than in nuclear power. 1973, France reacted to the oil crisis by building out its entire nuclear program. During the late 80s, early 90s, the UK had about 30% of its power from nuclear. We're about half that now. Floating nuclear power plants. I used to be the system engineering manager for a dual unit PWR in New Jersey in the US. It was run by Public Service Electric and Gas. And PSEG is famous for having pursued the Atlantic Power Station, which was supposed to be a floating nuclear plant, 2 full-sized 1,150 megawatt units stationed about 2 miles off the coast of New Jersey. It got very far along on the permitting process. And then after 3 Mile Island and the general lack of enthusiasm for nuclear, it was finally killed. But the engineering was sound. So the bottom line is, we don't need to reinvent anything here. We know how to do this. I think we're just kind of like learning how to rebuild the pyramids. You know, we forget how to do stuff over time. But consider this a call to arms. Let's get this going. We are running out of time. They say the best time to plant a tree is 10 years ago. The second best time is right now. Nuclear power.
Brilliant, thank you. And then I guess sort of bringing it now back to ports and how they're planning their energy strategies. Joe, if I come to you, I guess, I mean, you've had some interactions with port authorities. How are they looking at their sort of long-term energy resilience or energy planning?
Some are, some aren't. There are some feasibility studies going on. There are some ports like Seattle that has adequate hydroelectric power. Their greatest user right now happens to be a scrapyard, and they're looking to be able to plug in everyone there. Other ports really aren't looking at this. They're waiting to see what happens. I'm seeing on the facility side, you have chemical plants, you have steel plants, you have others that are looking to get off the grid because they are a high demand user, and when there are grid issues, they are asked to reduce some of their power consumption.
Yeah, makes sense. And I guess then, Richard, from the UK perspective then, do you see ports looking to take a more active role then in their sort of energy strategy planning? Or is there still the sort of sense that we'll wait until the grid will come through?
No, I think they're starting to look to sort of the medium and long term now. I think there's been a realization that you can't wait around for a decade on a possible grid upgrade, and the private wire, as we term, so these microgrids, it really has to start to be considered. And you're starting to see it in other ports. I mean, it does vary on the size of the port and the nature of their business. So, for example, within the UK, some of the ports are, located in big industrial hubs. They're facilitating the movement of goods in and out, and it's obviously efficient to have the manufacture close to the port for shipping. Other ports are a lot smaller. But from what I've seen, because I do actually work for ports throughout the UK, not just ABP, there's a common trend that all ports are looking to decarbonise and, in line with shipping. But it is challenging, as we've sort of alluded to today. The grid issues are serious in actual fact. We were talking about the Heathrow incident. Some of you will be aware of from a few months back, where there was a total outage at Heathrow. That was traced back to a transformer that was 60 years old. And that's Heathrow. It's not a port. It's in actual fact. So what's the rest of it like? So I think there's a move. There is a move to they're looking at how they can decarbonise, and we have to look at different energy solutions, of which nuclear is right up there. So
No, yeah, exactly. And I guess then maybe coming back, actually, so if we then widen the lens, and I think Joe briefly touched on it as well as Myrto, if they do have access to this firm, reliable, emission-free energy, I guess, what else could that begin to unlock? What kind of end users do we think, I guess, could start to form around no longer a port, but maybe an energy hub? Maybe if I start with you, Myrto.
Yes, thank you very much. What I didn't say earlier is that Voices of Nuclear and the Toronto Institute that I both represent today stand from the perspective of the beneficiaries. It's advocates, advocacy organizations and think tanks looking at making sure the nuclear industry does its best to serve the people and to serve the economy. And it is important in that port conversation to bring that perspective, because beyond the grid issues that are tremendous, the grids all over the planet today have to ensure their maintenance, their adaptation to climate change, their expansion, their strengthening, and connecting multiple and additional sites and energy points, going both ways as far as intermittency and all those willingness to decentralized grid. So they have a lot of pressure on them, and this is only an additional one. So really getting out of that constraint is super important and something that is central. But beyond that, what we understand is that any port operator that we've talked to, what's important to them is that they have access to a plant that's profitable. That makes sense, isn't it? Profitable plant means a couple things. It means, as far as the quality and of the power itself is concerned, the quality is against fossil fuels, of course, decarbonation and air pollution, because they will be targets of additional taxes, of regulatory constraints that will impact their operations. But it also means, and there is a couple studies, which is kind of a new field of study and of knowledge right now, going on, especially in EPRI in the US, and the Tandem program under CE leadership under the roof of the European Commission, going on how integrating SMRs and AMRs into energy hybrid systems. And those studies essentially lead to one interesting conclusion, which is that all the sensitivity analysis to price and to profitability come down to gas prices. This is the most impactful element, sole element, even well and beyond everything that you could think of to challenge that, which is storage capacity, oil demand, biofuels capacity, CO2 prices, and so on. So it is, and you have to add to that the factor that gas price can also fluctuate and is very much liable to geopolitical and market disruptions. The quality of the power is also important if you rate it against renewables, intermittent energies, because if you want to do hydrogen, and from that hydrogen to go through all the e-fuels and ammonia and methanol and so on, you will need electrolyzers. And the most widely used electrolyzers today, which are alkaline, cannot run on a power that's not stable. And we will go at some point to SOC electrolyzers or high temperature, but those haven't seen really the light of day yet. The quantity of the power that the SMRs, the FNPP, are able to deliver to the port and to the port operators is a total game changer. It goes well beyond the needs of just the terminal or the port itself. It can address many, many other uses that we talked about briefly earlier in my introducing remarks, but it can also serve communities. And finally, there's another mission of FNPPs that generally we don't talk about, but surprisingly today we've already mentioned a couple of times, and Admiral Richardson as well, which is using FNPPs to provide power onshore from an offshore perspective. And I want to share with you an actor that we haven't invited today, but that's important that we keep in mind. It's a company that's called Car Powership, which is a Turkish company, and it has 36 coastal gas ship power plants, essentially in South Asia and West Africa, and delivers power to cities. It's equivalent today to 6 gigawatt that it delivers today on floating power plants, but except they're gas power plants, right? So we don't want those. Which is the equivalent of 50 FNPPs of 100 megawatt electric plants. So we have our market, it's open, it's right there. And today the price of power, quite outrageously, to be honest, because it's around $200 the megawatt to Ghana, for example, for gross electricity. So it's there is a business case. You could also say there's a moral case to be done there, but finally, to not be accused of passing this issue under the table, we need to recognize that there is a security and safety issue into including nuclear power into a hybrid energy system and an energy hub on a port, because quite simply, the more you multiply the number of pipes, the more you multiply the potential points of single failure. So yes, that does increase the size and the necessity to have a robust safety case. It also increases the quantities and the scale of the potential cascading events. But also what those studies that are going on right now recognize is that at no point safety should be a blocking issue, and is not. And there is a lot of perception out of it, and it's more an energy hybrid system that is an issue in itself, and it's quite of a novel thing we're looking at, rather than nuclear, which is only an additional point to it, and not what really displaces the cursor in that regard.
Yeah, no, I think it's an incredible, I mean, the business case will have to make sense, I think. We can't overstate that, but it's also important to understand what is sometimes overlooked in the value of dependable emission-free energy, and it has been overlooked. But obviously nuclear has a massive strength there, particularly if it's providing sort of baseload energy. I'm conscious of time. I think we're coming up to the end. Is there any audience questions? Probably have about 5 minutes.
Yeah, excellent panel. Kevin Reynolds with Gloucester. So adding to the historical, I think it's important to realize that Russia actually built the academic Lomonov in 2019, and that's currently in service with 6 more floating nuclear power plants included. And with that, they're providing not only electrical power to the grid, but they are actually doing the district heating. Question to the panel is, we're keenly interested in seeing floating nuclear power to ports and waterways. Question to the panel, what do you see as the top 2 barriers to more widespread adoption, and why?
When we talk about floating nuclear power, I think there's 2 separate categories. One if you have a floating nuclear power station that's surrounded by a breakwater and it's in a permanent space, it's going to be a lot easier to license than something that moves around. And then if your power station has its own propulsion system, that causes a really big problem under American law because, and in fact, during the eVinci presentation, the presenter mentioned ITAR, which is the International Traffic in Arms Regulations. And the US regs are different than the European regs and the UK arms regulations in that all nuclear propulsion is considered a military system in the US. So that means Americans are forbidden from working on or supporting any foreign program that is dealing with nuclear propulsion. So if you have Americans working for you in nuclear propulsion, it's not legal. They could get in trouble. So I think job one for the American side is to get those the interpretation of that regulation. The U.S. Munitions list says naval propulsion for nuclear naval propulsion. So step one, I think, for this group, if for the American side anyway, is to get that changed, probably during the Trump administration, because the Trump administration is trying to get quite a bit of nuclear done. So I think the time is right to do that. With floating nuclear power plants, I think it's pretty straightforward that you could use the land-based system. If they're not moving around, you're going to be under the nuclear liability conventions if it's a Vienna country or if it's a Paris country or a CSC country. The domestic terrestrial nuclear liability regime will apply. Now, if you have something like the academic Lomonosov, the Russian one that gets towed around, that's a different safety case there. You're looking at it could have different environmental conditions, and if you're off the coast of, I don't know, say Spain or something, it's going to be different than if you're off the coast of Japan. So it does make things a little more complicated. So I think what needs to happen is we eat the elephant one bite at a time. If we start with a permanent floating nuclear installation, that'll be easy to license. Once people get used to that, you could move on to these more modern kind of concepts of barge-powered nuclear.
I can give a shot to that question really quickly because in interest of time, coming from the nuclear industry and from the more traditional nuclear industry, but being enthusiastic about the new one coming up, I must say technological readiness, in my view, is something that we should be aware of, that we should acknowledge, that the reactors that we look to are not going to come as fast as we would like them to, as fast as we sometimes talk about them, and we will have to sustain that delay in between and make sure we keep motivation, enthusiasm, and good conditions in place the time that they arrive, and have them arrive as soon as possible. That's the first thing. The second thing I would say is public acceptance. Not public acceptance as such, but we've talked in the earlier panels about how there was an industry push to regulators and politicians to put the framework in place. The reality is that regulators and politicians will move more or less fast depending on public opinion and public acceptance. Is it a political gain or is it a political cost? So we will need that public acceptance. And if it's there, what I call the human limits, we will make them move pretty fast. The technological limits, the physics limits, are something we have less of our hands on, and they may take their own time.
I want to make a little correction. Vincent, I know that there are some efforts underway right now to get nuclear propulsion in a civil environment not be under the jurisdiction of the international trafficking in arms regulations. So there have been some recent activities in that area that aren't quite public yet, but it's not truly the case right now that all nuclear propulsion in the U.S. is subject to ITAR anymore. So.
Could I just say one quick thing as well, actually? Because in actual fact, it's quite important, I feel, for the crowd. Ports aren't well represented, unfortunately, here today at the moment. There's been a lot of good talk about international standards, standardization, and works. None of that applies to ports. There is no international standard, and there is no international framework for how ports are run. That makes it a little challenging because the industry is going to have to engage ports at the local level, national and local level, to understand how they can get these FNPPs and potentially vessels into the port. Because you might meet national requirements, you might meet international requirements, you might meet national requirements, you might not actually meet the local requirements of the port. And that is something that will need consideration.
Brilliant, thank you.
Could I just add one? I know.
I'm going to get called off stage soon.
You've seen a port. You've seen a port. And there's different types of ports. Some are landlord ports, and really the Port Authority doesn't care about what's going on. So when you're making a business case, who are you making that business case to? The tenants, the operators, or who? And that's a challenge in a lot of locations.
And I really...
I'm sorry, I'm going to get dragged off stage soon.
No,
But please, I'll hand back to Charlotte. Thank you all of our panelists.
Thank you.